All right, so applying mean value theorem to a rectilinear motion.
Rectilinear.
Yeah, something like that, right?
Well, he can say that.
I know the foreign guy is actually telling me how to say it in English. Thanks. Okay. Thanks, Fez. All right. Use mean value theorem to show that a car travels at 110 miles, 2 hours, must have a speed at least 55 miles per hour, at least once in 2 hours. Okay.
What is rectilinear? Rectilinear. Or how it's right? Rectilinear or rectilinear motion. What does it mean? What is rectilinear?
I don't know. Like to move it. That's what it is right there. Okay. At least once in 2 hours. Okay, so let's take a look. Let's start off with first figuring out what is the actual average speed of that? How would I figure it out? What's my initial? What's my initial?
Oh no, wait.
Initial values. What's my initial time?
0.
Thank you.
Oh.
It's going to be time. So when time is t is 0 and t is 2. Okay. So what is my s of t? What is my initial position?
0.
Right? And so s of t is also going to be
110. But it's S2 of T. It's not the same. Wait.
yeah.
S1 and S2.
Oh yeah, you're right. Sorry.
Just mark it.
Good job, Fez. Here. Have some donuts.
What? That was unexpected.
So if he's eating, hopefully he's not like talking crap
Oh
during the whole
yes,
movie.
yes, yes.
Okay, so those are the things I really needed to know. Okay, when you're actually talking about this, you have to know your initial values and your end values. So you have to think about it, read through the whole thing to actually get some of that stuff. So mean value is finding the slope in between these two, right? Find the mean, find the average, right? So it would be, for this one, it would be 110, right? Minus 0 over 2 minus 0, right? Because it's going to be T1, T2, so it would be S of T2 minus S of T1 all over T2 minus T1. So we're trying to find, we're using a slope formula for a position here. Okay, so we're actually just finding the average velocity of here. Because velocity, so the absolute value of velocity is actually your speed. Yeah, and so if there was a negative velocity, that means it would be going backwards or down, in whichever our function is. And if it's positive, it's going away from the initial start. Okay? So, given this much information, I'm going to come up with that since it's going to be average velocity, it's going to come out to be 55. So I get 55 mph. Ah, crap. Man, I even misspelled mph. Wow. Okay, 55 miles per hour. There we go. Woo! At least once. So somewhere in between there. Okay, but you could start off. So most cars don't start at 55 miles an hour, right?
Yeah.
So when you like turn it on and all of a sudden hit the accelerator, you're not at 55 miles an hour already, right? No. Okay. You start at 0 and you accelerate to that value, right? Okay, so therefore, it's not going to be a constant rate the entire time. So if he's going 55 miles per hour, like has to accelerate at first, that means that at some point he also has to be faster than 55 miles an hour to make up for that time, right? Yes? No?
Yes.
So y'all in here drive?
Yeah.
Okay,
of
I
course.
got a driver here.
Not well.
Yeah, we're driving. I'm just driving every day.
I drive.
You drive?
I just became 16 and I started driving right away.
Driving here?
Yeah.
You are?
Yes, I am.
Okay.
I have a Porsche on the back of the school.
The Porsche.
Yeah. Do you wanna go and see?
It's a bicycle.
I you know, strange flex, but you know, I'll go with it. All right.
Oh yeah.
Yeah, I know. He's like, all right, yeah, I drive a Porsche. Yeah. Okay.
Yeah,
He's a
Anyway.
funny
Every
guy,
day.
right? He's a funny guy.
Yeah. Anyway, so if you're driving and you know that you're running late to school, what do you do?
Accelerate.
You're already
Let's be
late.
that.
Okay, thank you. That's a smart thing. But okay, a lot of people speed up. Why do you speed up?
So you can get faster.
To make up time, right?
Yeah.
So that means that you were going slower, but you still want to try and make it there on time, so you have to speed up.
But you also don't want to get arrested.
Yeah. Okay. Yes, that's even better. Okay. Does that make sense?
You.
Hey. Does that make sense? Even for people not driving?
Yeah.
Me?
Okay. No, this one that's not driving a Porsche.
I know what you're talking about.
All right.
Because they don't have cars in Ukraine.
Yeah.
Yes, you got the
We
horse
got
and the
horses.
buggy, right?
Yeah.
I know you're
Actually,
cracking that whip faster.
Actually, in the villages, they still use it.
Huh?
I'm seriously using it in
The wizards?
No, in villages.
Oh,
They're using it. Like
Villages?
Villages.
It's like to sing about his country, right?
I don't know how to say it, but they use it. Like,
Oh, okay. We have people that still use them too.
I don't
Rednecks.
believe it.
Amish.
Are you talking about yourself or what?
Man, seriously, I wish I could do some horsepower. I get tired of paying for gas. Yeah, so
Buy a horse, what's the
they're
problem?
huge.
anyway, listen. I grew up in a farm community. Our high school had a horse stable.
Hey,
People rode their horses to school,
that's fine.
For real?
That's fine.
Yeah.
That's
but they also had what's that agricultural thing?
Okay, I got it.
I don't know, like Napoleon Dynamite was in it or whatever, like FFA or something like that. Yeah. Anyway, but yeah, we actually had horse stables on our campus.
that's lit.
So
Why not?
I don't know. It's good for the class, and then people that ride just drop off their horse and they're like, okay. Anyway, but still, here, f prime. If f prime of x equals 0 for all numbers in a to b, then f is a constant function on the interval. So what does that mean? If it's a constant function, that would be what?
It's the line.
That would be just like a number 3 or something, right?
Yeah.
So that means that the slope would always be 0. Okay, that's what it means. Okay? So, oh crap, I could never say. Anyway, all right.
Corollary.
Okay, if a function f is continuous on the closed interval a to b and is differentiable on the open interval from a to b, and f prime of x is equal to 0 for all numbers x, then ab, then f is constant on that. In words, if an object in linear motion has a velocity of 0, then the object is at rest. Is that all right? So if the velocity is 0, and I said that speed is the absolute value of velocity, right?
Mm-hmm.
If speed is 0, even in your Porsche, you should know this. You're not going anywhere, are you? Okay.
Maybe. But the Earth.
Anyway,
is
stop talking.
and
All right.
moving around the sun and all the time in motion.
Hey,
But it's still motion.
eat a donut.
He ate them all.
I ate all
I know,
donuts,
right?
Sorry.
Oh.
I got out of donuts.
Anyway, here, function g differential open interval a to b f prime is equal to g prime for all numbers in x, then there is a number c for which that the function plus c on the open interval. This is actually leading into our antiderivatives. Our antiderivatives or your integration. This is actually coming up.
Integrals?
Yes.
Oh,
Integration, yes. That's what I said.
Substitution to this thing.
Okay. For this right here, increasing, decreasing, if it is differentiable on the open interval, then f prime of x is greater than 0 on that interval, then it's increasing, right? So if the derivative is positive, it's going up, right? The slope is positive, it's going up. Okay, if the derivative is negative, it's going
down.
Thank you.
Can I ask a question?
Oh my goodness.
No.
That was a question.
Just short, no. Please.
Go ahead.
Are we gonna have a blood magic in integrals?
Oh, blood what?
Like voodoo magic.
Oh
like
my
in derivatives.
oh. Okay. All right, determine the function is increasing and where's the decreasing. So let's start off first by taking the derivative. Take the derivative.
6x squared minus.
Okay, yes, thank you. So f prime of x is equal to 6x squared minus 18x plus 12, right?
Yeah.
Can I f that?
Yeah.
What can I f out of it?
Can you 6?
Yeah, take out a 6, right? So that's going to make math a whole lot easier. X squared minus 3x plus 4. All right, so what this is actually saying is find the places where the derivative is equal to 0. And in between there, those are going to be your changes in derivative. So from here, set it equal to 0. What's going to happen to that 6? Nothing, right?
Just this
Yeah, divide both sides by 6. What's 0 divided by 6?
0.
There we go. Good. Equals. Now, for this piece right here, can I factor that one? Yes, I can. It's a trinomial. I could factor it. What that multiply to be 4, but add together to be negative 3. So it's going to be
Oh, I chose.
no.
It's not 4 in the end, it's 2.
Oh, you're right. It's 2. Sorry, man. I already gave that guy donuts and he still hasn't stopped. Okay, there we go. So it's going to be. Let me see. That's going to be x. Let me see. Positive. So it's minus.
Minus 2 minus 1.
There we go. There we go. All right. So that means that those are the places in which that the slope is equal to 0, right?
Yeah.
Okay. So I'm going to have x equals 2 and x equals 1. So on a number line, so I have 1 and 2. So I'm trying to figure out where this is going to be positive and negative. So what I'm going to do is, since I have a number line here, let's pick a number on the left.
0.
Okay, 0. Plug it into the derivative. Plug it into the derivative. So I'm going to plug it in right here, and that's going to make it a little bit easier for you. Because you're just looking for positive or negative, right? So this, if I plug in 0 to this first part here, that's going to be a negative. And this is going to be a negative, so that means that is. So I get a positive for all that, right? Okay. Let's see. In between 1 and 2, 3 halves? 3 halves, right? So 3 halves, so it's going to be 1.5. So that would be a negative right here. This would be a negative. And this one would be a positive, right? So a negative and a positive? Negative. So I get a negative here, right? So from here, I'm going to put it down here. There's a negative. Okay, so let's do a number on the other side of 2. So let's say 3. So 3, this is going to be positive here, right? And this is also going to be positive here, right? So therefore I get positive. All you're looking for is the sign changes. That's all we need. It's just the sign changes. That's why I'm plugging in there, not the original. Okay, all I need to know, positive or negative. All right, so with that information right there, let's go with it. So I know that it's going to be increasing and decreasing. So it's increasing on the interval from negative infinity to what? To 1. And is that going to be a bracket or parentheses? Parentheses. Because what happens at 1? It is 0. Okay? It is going to be 0 there. All right, it's increasing there, and it's also increasing where? Parentheses, 2 to where? Pause infinity, and always close infinity with a parentheses because it is an idea, not a number. And it is decreasing. And that's from 1 to 2. Is that pretty easy? Okay, good. Close.
Agricultural economics determine what?
Okay. Trying to make sure I get all this stuff done. All right, so determine where the function here is increasing and decreasing. So, first thing is what? Derivative. What rule am I using there?
Chain.
Yep, chain. So, it's f prime of x is going to be 2/3 x squared minus 1 to the what power? Negative 1 over 3 times 2x, the derivative of the inside. Now, I'm going to clean this up because I want top and bottom here. Because that's going to help me out when I'm setting something equal to 0. So that means on top I would have what?
4x.
Very good. So 4x. On the bottom, I'm going to have 3 quantity x squared minus 1 to the positive 1/3. Okay, because I'm moving it to the denominator, it becomes a positive 1/3 here. All right, I like that problem very much. That one's going to be so much easier. Set it equal to 0. 4x equals 3 quantity x squared minus 1 to the 1/3. The reason why I like this is because 0 product.
Yeah, only 4x can be equal.
Yeah, because multiply both sides by the denominator to clear out the fraction, right? So I'm only going to have 4x equals 0, right?
But we need to tell so that x is nothing to 1 and negative 1.
So x is
0. And it's equal.
all right.
That's all?
Now, let's look at our information though. Looking at our information there, look at our function. Is there any restrictions on my function?
Yes.
Is there?
Yes. Like on the function now.
What is the root?
Third.
It is the third root, right?
First, no. Oh, yeah.
It is the third root. Are you allowed to have negatives in a third root?
Yes.
Yes, you are. Okay, so that's good. So I don't have any issues with my function. Now look at the derivative. Look at the derivative right here. Okay, I'll show you right here. That derivative. Is there any restrictions on the derivative? Where can I not take a derivative at? At 1, right?
And negative 1.
What's going to happen to 1?
0.
It's going to give me 0 on the denominator, right?
Yeah.
Negative 1 is going to do the same thing, isn't it? So I cannot take a derivative at 1 and negative 1. So it's going to be some type of cusp. Okay, some type of hole on that one right there. The function is continuous, but I cannot take a derivative at those 2 points. So I wanted to show you what this is going to look like. So we know that right here, so the left side's going to be something and the right side's going to be something. But I'm also going to have a little issue with the 1 and -1. Okay, because I can't take derivatives at 1 and -1. So let's take a look at this function. So I'm going to pull up my calculator and graph this one. So my function was parentheses x squared, right? I know you guys are doing this, playing along with me, right? X squared minus 1 caret 2 over 3. There we go. So that means that there is a change right here. Because of the derivative, these are cusps or kinks right here. These are kinks on this. So for this, it means that that is a change right there. So that means that I have a couple different things here. So it is, the slope is going to be negative to 1, right? Negative to 1, and from 1 to 0, it's going to be positive. It's increasing, right? And from 0 to, it's decreasing, right? And from 1 to infinity, it is increasing. So, even though that we only got a 0 out of it, I had to deal with the values when it is not differentiable. So again, my points on my number line were 0, and then where I couldn't take a derivative was -1 and +1. Okay? So we said, because of these ones right here, these are where I couldn't take a derivative. So that means that something is changing there. There was my kink. So this was a negative here. This is a positive, this is a negative, and this is a positive, right? That's what we ended up getting from the graph. So when you take a derivative and we're looking for stuff like that, I have to look at the domains of the function. See if it's continuous. Domains of the derivative to see if there's places in which that I cannot take the derivative, like this one right here. Does that make sense now? A little bit? Does that help you a little bit? Okay. Hold on. Let me see. This one. Okay, so I'm not going to do this one, and we're just going to talk about it real quick. What would I do for this one right here? For what amounts of potassium will the yield increase? For what amounts of potassium will the yield decrease? Do the same thing, right? Take the derivative. Set it equal to 0, right? Yeah. And check your numbers. So if my slope is positive, it's going up, okay, that the yield is increasing. And if the slope is negative, that means the yield is decreasing. That's all we're doing here. Does that make sense? Okay. All right.
Don't forget, like, share, and subscribe.
Like, share, and subscribe.